So here we are again this week, and welcome to another episode of the Capricorn People podcast with me, Guy Bevington, MD of True North Recruitment Group. And here we feel this is a podcast for global technology leaders to share insights with the tech community. And this week I'm delighted to be joined by none other than Phil Deutsch. Phil, welcome. How are you?
Yeah, really good, thanks. Really glad to be on the podcast.
Good, great. Well, a warm welcome, quite literally a warm welcome. It's absolutely scorching today, isn't it? It's approaching the high 20s, which is what we like. So yeah, Phil, I guess to introduce you and the frame of the podcast today. So for those that are yet to make your acquaintance, you are the head of data science for Capricorn Capital Partners UK. And we got chatting quite recently, and I think we were both agreed on one particular area that, you know, given the hype that exists around data science in the world today, you know, a lot of companies can often see it as this magic fairy dust that you sprinkle over any tech problem or data problem, and you'll uncover some revolutionary algorithm, or, you know, there was some huge cost saving for the business. And I guess the beauty of your role is, given the varied nature of the different clients you work with, you get to see a lot of different strategies, a lot of different variations around, you know, different companies, different problems, and it'd be really interesting to see how those different approaches vary with regards to their data science practices. So I thought it'd be great to get together and just sort of discuss that really, and see if there's any common themes that seem to be emerging. And but I guess before we delve into that, I'd love to just invite you, if I may, to tell us a little bit about yourself and in your career to date, and we can go from there.
Yeah, absolutely. So my background originally is in, so I studied maths and physics at uni. And actually, when I was, like, as a student, I was really into my science fiction, like I guess a lot of people in data science. Especially keen, or I love Asimov and the Foundation trilogy. I'm not sure if you've ever read that, but one of the core themes there is this thing called psychohistory that they do, and it's basically a branch of mathematics that allows them to predict the behavior of people if there are a lot of people in behaving together as a group. And I kind of was fascinated by this stuff, and I think the closest to that description is actually data science and kind of machine learning. And I really got into that after uni, when I started working for a bank, and that was kind of 10 years ago now. And banks then were, I think, the first industry to really use, you know, machine learning models to predict things like, the likelihood of somebody defaulting on a loan and the exposure at default and that kind of stuff. So I was really learning about how to use data and how to make predictions based on data in financial services. And then after a few years, switched into consulting. I think that was mostly because I have a relatively short attention span, and it kind of suits me well to kind of work on a project for 2-3 months, and then kind of have a different problem to grapple with. So worked in consulting for quite a while, saw quite a few different problems in different areas where I could apply machine learning or data science solutions. And then joined Capricorn Capital Partners 4 years ago now, where I joined as the head of data science and have kind of built a data science team. And what we're doing at Capricorn is using data, using analytics, machine learning in any kind of shape and form, to help our portfolio companies basically be as scientific and as effective as possible. So we're really, we're kind of like an internal consulting firm or team for our portfolio companies, so we don't work with anybody else. But obviously we have a longer time horizon, right? We're investing in these companies, and we're working with them over the course of years to try and help them as much as possible.
Yeah, fantastic. Well, thank you for that. That's a great, really impressive background, and I guess really nice, well-rounded background from the finance side and then the data science side. So clearly somebody very qualified and capable to talk about this, I guess. So yeah, to talk us through then, so far, your experience of data science, how it's being used in the private equity space, and just any kind of common themes that you're seeing within your portfolio companies.
Yeah, sure. I mean, I think in terms of data science, there's really two very different areas. I think there's the cutting edge research kind of data science that's done at universities, but also at companies that are really machine learning first, let's call it. And then there's, I think, a separate type of data science that if you're just selling shoes online or whatever, you might want to use data science, but then you're just applying algorithms. You want to increase conversion, you want to decrease churn, that kind of stuff. So the companies that we invest in are kind of very firmly in that second camp, right? I mean, we're trying to apply machine learning tools and to use the data as best as we can to basically help solve common commercial problems in those companies. And it's also worth noting that at least Capricorn, we are not really using data science that much in the investment area. So we're obviously making a lot of decisions around how to invest or who to invest in. These decisions are not really automated in any way, or we're not using data science that much. So we're really focusing on clear commercial problems within our portfolio companies where we can apply some predictive algorithm, and ideally where we can also use our findings and in a way productionize what we're doing to kind of deploy to the different portfolio companies.
Yeah, fantastic. Yeah, I mean, I can really see the value there of how data science used in the right way could be a very powerful tool, and like I say, replicated across different companies in the portfolio. Certainly seems to.
Yeah, absolutely. I mean, I think it's the replication is a big factor, but I think it's also that data scientists are not exactly cheap, and a lot of our portfolio companies would very much benefit or do benefit very much from having access to a data science team, but they couldn't really hire or retain a team of data scientists. They might be able to hire one, but that person then would have no clear career progression path or anything like that. So we basically also from that perspective found that it's just much better to have a central team of really good data scientists who can reach this level of scale. So we're currently 5 data scientists, so there's kind of at least some room for discussions. You can have whiteboarding sessions, that kind of stuff, and we can then work across those different portfolio companies, and each of those companies can then benefit from having access to that pool of expertise.
Absolutely. Yeah. It's a real win-win, I guess, isn't it? From the way you can execute it, and also from the client's perspective, like you said, getting a very
exactly.
But data science team without necessarily a huge initial investment. So I can hugely see the value there. Okay, great. So talk me through then, when you are going into a client, you're assessing the situation, the lay of the land. What approaches, what sort of hygiene factors are there to consider when you think about embarking upon a new data science initiative?
Yeah, I mean, I think it's a bit weird. Like, data science is in a slightly weird place where it's been around for a while, obviously, and there's a bit of a hype now, and then that still hasn't died down, I don't think. And I think people can have quite unrealistic expectations, in the sense that if you just sprinkle data science or kind of throw data science at a problem, it will just kind of go away, and the black box, the black Keras box or whatever, will just solve it. And I think that kind of can lead to a bit of disillusionment, or kind of it lead to people being then disappointed with the results, because then quite often there's a disconnect between what the data scientist builds and what the business actually needs. And I think a very, very large part of my job, I think, is actually in translating between what a product owner or a commercial user needs into a technical framework, into a technical problem that effectively can be solved using or optimized using an algorithm. Because quite often the initial brief is something like, let's reduce customer churn, or let's optimize marketing spend, and it's something quite vague like that. And then a huge part of the value that I think a data scientist can add is actually in making that clearer and making that concrete and measurable, and bringing the science to that whole question. And part of that can be, you know, building a machine learning tool to then actually optimize part of this. But I think even without that, there's a huge amount of value to add by just, you know, making all of these terms precise. You know, what does it actually mean to optimize marketing spend? Is it just about, you know, the return on advertising spend? Is it about customer lifetime? But like, there's a lot of different ways that this could be done, or that ideas that people could have about what that means. And so I think in terms of these hygiene factors, I think really the core is to have a definition of success effectively. And I think without that, it really doesn't make sense to try and build something complicated and then not quite know, you know, at which point does it actually succeed.
Yeah, I think it's such a great point. And I agree with you, by the way. I think that this whole data science phenomenon, buzz, whatever you want to call it, I think is yet to die down. I think, if anything, in many areas, the expectations sort of, because it's becoming more prevalent and well known in businesses in general, is sort of still on the increase, I think. And it's amazing, actually, when I speak, clearly in my line of work, I speak to a lot of data scientists on a daily basis, and you know, a lot of them do really share that frustration of kind of the heaped expectation that sits on their shoulders, that, you know, you can just sort of throw this machine learning algorithm at a set of data and it's just going to solve the world. And you know, as we all know, really, a data scientist is only ever going to be as successful as the quality of the data that they're working with, and very often it sits behind, you know, way further behind what a data scientist is actually capable of doing. And I think, yeah, what you're describing there is a really pragmatic approach to that whole analysis piece right at the beginning, and you know, sometimes, quite frankly, it isn't the right solution. I think that's something a lot of companies could really benefit from hearing. But with that in mind, I mean, what do you feel are the sort of key indicators that you would measure as to whether you feel a machine learning solution should be used?
Yeah, I mean, I think yes, I think there are some clear situations where I think it makes a lot of sense, and I think the perfect scenario where I'd say, you know, we should really think about a machine learning solution is probably where there is a process that's clearly defined, that's being measured, and where some steps have already been taken to optimize it, but basically that then reaches a plateau because there's only so far you can take this without using something like machine learning, right? I mean, if you're already optimizing your conversion funnel or whatever, basically manually using A/B testing by, you know, region and customer group, there's only so far you can take this. And I think that's when it makes a lot of sense to then say, okay, in order to properly personalize recommendations on a website or whatever it is, you actually have to use machine learning. But I think ideally you want to do that once you've had a proper stab at A/B testing and optimizing and tracking the performance first. And I don't think you want to leapfrog this and go straight into machine learning algorithms without having that basis first.
Yeah, totally agree. Okay, cool. So when it comes to the rollout of a data science initiative, the world of data science obviously sits quite closely with software engineering, and it's quite a well-known, well-trodden path, I guess, in the software engineering world, about certain methodologies that exist out there to successfully deliver software. You know, obviously all know the likes of Agile and Scrum and Kanban and different methodologies out there. And are there particular methodologies that you employ working in your team of 5 at the moment that you would use to execute a data science project?
Yeah, I mean, I don't think we're really reinventing the wheel there, but I found that a version of Scrum with a kind of Kanban board works really well. So most of the projects that we're doing are running on weekly sprints. So basically, we have a roadmap that has the high level tasks, and those are broken down into tasks that are, then slotted into 1 week sprints. And I think one of the key learnings there is that, especially with machine learning and data science generally, it's very tempting to have, huge tasks that then just sit there in progress status of a Kanban board for like a week or whatever, or 2 weeks, because the task is then effectively build a model or something. And I think ideally you can break it down into very, very granular chunks, which I've found to be very, very helpful, because the more you can constantly have this flow of tasks through that through the different statuses and through these sprints, I think the easier it is to spot when somebody gets stuck or something isn't working as expected. But yeah, I think that's kind of a key aspect. I think another one is something that again we haven't invented, but it's kind of a very agile mindset, in that with machine learning project, or I guess with software development in general, it's very tempting to just go away for a month, build something, and then deploy it. But I really believe that data science in particular is a contact sport. You want to be as close to the users of this tool or this model as possible. And so having very regular check-ins, making sure that at the end of each sprint there's something very tangible to show and for somebody else to use and play with and then feed back on. I think that's extremely important, and I think it's something that I don't think comes natural for a lot of data scientists, who tend to be, and I definitely include myself in this, tend to be somewhat more introverted and want to just go away and build something great and then show off our great creation. And I think in reality that just doesn't really work that well.
Yeah, that's another really good point, because I guess in the world of data science, very, very often is that conduit with the business and understanding how what you're doing is impacting on the business. And like you said, often there can be culture clashes, personality clashes from both sides of the coin, I guess. And I mean, how do you personally manage that, and how do you build a successful data science culture, within your particular team?
Yeah, I think one of the key things I think is that ideally these projects are much more cross-functional. I think when you just label it as a data science project, to build a recommendation engine or whatever it is, I think this makes it a lot harder, because then you're automatically building in these silos, and you almost have you have the data science team producing something, and then just building that mindset of the data scientists are just the data science work ends where that product is deployed or whatever. And I think a better setup is to have a cross-functional team where the team has a clear objective, like, I don't know, let's improve conversion on that particular website, and we want to do that using a recommendation engine, say. But then have a front-end engineer on that team, have a product owner on that team who understands the customers, and have one or two data scientists on the team. But basically, the more I think you can foster that cross-functionality, the better it is, because I think it's important for the data scientists to always feel and see that they are, I think, ultimately, we're a support function for, other parts of the business, and they have actual commercial, metrics and problems that they want to solve. And it's not just a academic problem that's, solved by data scientists in isolation.
Yeah, totally. I think that's the mark of a great leader in the data science space, that they really foster that element of collaboration with the rest of the business. It's certainly a common theme that I've seen. Seems like you're similarly echoing that, which is fantastic.
Yeah.
Okay, great. And bearing in mind your time now as a leader in the data science space, what do you feel are the biggest lessons that you've learned that you could perhaps share around either data science practices internally or those potentially with any of your clients? Are there any kind of big lessons that really stand out to you?
Yeah, I mean, I think maybe it'd be useful actually to have different names for this, because I feel like it's hard to talk about data science because so many different things are falling under the data science umbrella, and it goes, I mean, one is, data science and machine learning being used interchangeably, and kind of for me, machine learning is, clearly one tool that a data scientist uses, and it's not kind of the same thing. But it's also within machine learning or data science, you have a huge gap between, the cutting edge, research, the what OpenAI is doing and what you read about AGI and all of that stuff and GPT-3, and then you have what most companies are actually using. And I think that gap is widening, if anything, because it's just the cutting edge is just so far removed from really what most companies are doing, and realistically also what most companies need, right? I mean, very few companies need deep learning models really, but almost every company could be better at making, doing experiments and making scientific decisions, capturing the data, and yes, simple machine learning models might also be a good idea. But you're then, I think one of the challenges is that quite often the data scientists are obviously in that area because they're super interested in the cutting edge thing, and then they can get frustrated when they're building the seventh logistic regression model. And I think it can be hard to kind of bridge that gap in a way. But in a sense, I think it's so what I'm trying is to actually move a little bit away from that concept of data science means applying state-of-the-art machine learning models, and rather, to me, a core part of being a good data scientist is actually being an evangelist for using the scientific method in businesses, and using data effectively, and yeah, like I said, machine learning model is one of those arrows in that quiver.
Absolutely, yeah. And when it comes to building your team and kind of bringing people on board that kind of share that view, are there particular traits, characteristics that you look for when it comes to hiring good data scientists, in your opinion?
Yeah, I mean, I think obviously there's, there are technical hygiene factors. Everybody that I hire needs to be, quite good at, SQL, Python, ideally Python and R, and kind of know a little bit about that, these tools. But I think as important is, communication skills, and also, interpersonal skills, and patience, and just being able to explain these concepts clearly to somebody who isn't technical. Because we're a little bit a victim of our own success there, I think, because with the proliferation of fantastic tools like scikit-learn and cloud platforms where it's easier and easier to deploy that stuff, it becomes very tempting to just throw a lot of computing power and a very complicated algorithm at a problem. But you then, first of all, immediately lose anybody who isn't technical, and second of all, it becomes so hard to then troubleshoot when the output isn't what you're expecting, and you'll then constantly have questions from some non-technical person that's like, well, why did the tool recommend this over that, or whatever. And so I think for me, being able to understand what a non-technical person needs to know, and kind of explain that to them, and kind of being able to engage with them on that level, and kind of explaining machine learning algorithms at different levels depending on who you're talking to. I think that's a very, very key skill.
Yeah, I totally agree. I think that translation piece is absolutely massive, because I think also gaining the buy-in from the business as well. Like you said, it is very much a winning
Absolutely.
hearts and minds exercise, and people, I suppose, fundamentally, if they feel that every time they speak to somebody with a data science team, they just have no clue what's being spoken about, they'll just instantly shut down, won't they? So it's that
Yeah,
that ability to know how to phrase things to various people without being
yeah,
condescending, but also being informative. And I think it's a very difficult skill to perfect. But no, I totally would agree with that.
yeah. But it's I think it's actually also the reason why I kind of think, that you always hear these. There's some articles or some talking points that data science is going to be automated, or these all singing, all dancing data science tools are just going to optimize stuff for you. And I think in reality, this is the reason why I'm not worried about that at all, really, because I think um, the benefit or the value that data scientists bring it is not really the ability of writing the piece of code that trains a deep learning model. I mean, that becomes easier and easier, every month. It's really that translation piece and understanding the commercial side enough to know what to even apply in the first place, and whether that data, is good enough to be fed into an algorithm, and all of that, all of these kinds of questions that I don't know. At some point, who knows? But I don't see those, being automated anytime soon, or kind of not requiring that insight and that level of communication.
Yeah, I totally agree. That's a really good point, actually, because I mean, I'd almost extrapolate that out into really what I do as a job in recruitment as well, because for a long time recruiters have been worried about, is the job of a recruiter going to get taken over by some sophisticated AI algorithm that can connect talent and companies? And of course, whilst these tools and the fantastic tools that are being created all the time, which really help with that whole initial sort of matching process, there is still fundamentally, recruitment is a human business, and as are most businesses, really there's always an element of human interaction involved within it. And really, when a client is working with me, I always say really what they're paying for is my opinion. It's that kind of the bit that the algorithm can't really ever necessarily match up, because it's about how do I feel when I speak to that person. And who knows, maybe in future, a long way down the line, we'll have levels of AI that are that sort of sentient and sophisticated, but for a long time I still think there's always going to be that piece of human interaction needed to make sense of the data. If that makes sense in lots of
Exactly, and I think I guess when somebody knows 100% exactly what they want, in both of those cases, right, that can be automated, right? If somebody knows exactly, here's exactly the kind of job that I want, and I'm just interested in that industry, in that job, in that whatever, then yes, you could probably automate this, because this is a very easy matching exercise. And it's in the same way, if somebody has there's a very clear metric, there's a very clear process, and they just want to, and it's basically an optimization problem, then yes, you can just run it through an algorithm. But I think the reality is that in most cases it's not like this, right? It's people don't quite know what they need or what they want or what the lowest hanging fruit is, and they don't even know what questions to ask, because they don't know the industry, or they don't know the algorithms that can be applied. So that's it's a lot of it is understanding, basically connecting those two worlds, and basically being able to say, oh, actually, this is the problem that is much easier to solve than that problem, and so we should tackle that first, or whatever, and then applying the right tools.
Yeah, absolutely. I guess it's all about context, isn't it? Intelligence and context. So yeah, 100% agree with that. Okay, fantastic. Well, first, absolutely fascinating speaking to you. Really enjoyed the chat, and I always like to end every podcast by asking your opinion on what are you most excited about in the world of AI and data science moving forward. And you've mentioned, obviously, the world is progressing at a pace from the cutting edge data science point of view in terms of what it can actually achieve. But is there anything out there that really excites you moving forward?
Yeah, I mean, I think the cutting edge of data science is or machine learning, I think, is extremely exciting. I think I mentioned GPT-3 a little bit earlier, and I think that was the first example of, I think an AI system that really kind of completely blew me away as a, I don't have too much to do with these kind of cutting edge models, but that feeling of, this doesn't feel like a computer anymore. I think that's extremely exciting, and it's quite clear that we're still at the very beginning of this shift, and so I think it's going to be extremely exciting to see what comes of AGI and these machine learning models. I think closer to home a little bit, I'm actually also very excited about recent advances in ML ops, and I think that's an area that is still very underdeveloped in a sense, and there's no real standard for something like what GitHub did for software development. You don't really have, you have some GitHub-like things for data, but there's no real standard like Git for data or Git for machine learning models, where you could version all the different artifacts in the models and make it a lot easier to deploy these tools. Roll back to why did we make that prediction last week, and what were the inputs, what were the outputs. So I think in that sense, data science really lags behind traditional software development, which is not really surprising, right? It's so much younger, and we're kind of currently trying to shoehorn everything into these software development tools, like we're writing unit tests like you would for a static application, and I feel like there's no currently very good way of translating all of that into the ML world. So I think probably sooner than us getting fully fledged AGI. I'm really looking forward to advances in that field, and I think that's going to make it a lot smoother to actually work on these projects as well.
Yeah. I mean, to echo that sentiment, it's certainly something we're seeing on the recruitment side of the coin. It's becoming more and more prevalent within companies, and certainly around the ML ops side, becoming more aware of the need for possibly somebody in that space. But I think it goes back to the interesting point you made a minute ago, but a lot of the conversations we're having still are people not too sure exactly what they need yet. They've got a bit of an idea, but they're not sure what they need or why they need it. So but no, it's fascinating to chat with you, and I guess all that remains to say is thank you very much for your time. I look forward to following your progress intently in your role at Capricorn, and I'm sure we'll catch up again in the not too distant future.
All right, thanks. Well, great to be on the podcast, and take care.
Yeah, man. Cheers, Phil. Bye.
Bye.